In this presentation, we are going to study part of the chapter 4, which is heat and temperature. Today, we will focus on the kinetic molecular theory, phases of matter, temperature, and temperature scales. And we already studied the motion, or we are able to describe the motions of objects we can see. For example, car, ball, a person. But also we study the motion and the, for example, the motion of the moon or the motion of the earth. Then we study the motion of the objects we can see. And we also describe forces, work, energy, all these objects. And this part is the mechanics. And now we will move to another branch of the physics, which is the thermodynamics, and is related to the heat and temperature. Then what happens is when we add heat, when we add energy to some system, we change the system at molecular level. Then, for example, if we add heat to the water, at some points the water is going to boil. But the water is boiling because something happened at molecular level. And this is why the thermodynamics, we can consider that the thermodynamics, that is the connection between the macro world and the atom, and the world of the atom and the world of the molecules. And it's the connection between the big things, large things, and the things that is really tiny. Then in this part of the course, we will concentrate on this to study the thermodynamics, and at the end of the course, we will study the atoms and the molecules. This is more related to the chemistry. Then in this presentation, we are going to focus in the concept of the temperature, but let's first say heat and temperature, they are not the same. And one example in this case is we had two beakers, but in one beaker we had twice amount of the water. And these two, the water in these two beakers are at the same temperature, 100 Celsius, 100 Celsius. However, the amount of heat is not the same, and it's not the same because in one of the beakers we had the twice amount of the water, and this is why we had twice amount of the heat. And just now I want you know is heat and temperature, they are not the same, but they are related. And let's now study the kinetic molecular theory. What happened is 2,000 years ago, you know, the ancient Greeks, they was wonder if the matter was a continuum or was a very small, or the matter was made up of very small particles. Then just about more or less about 200 years ago, Dalton, he was a chemist that studied chemical reactions. Then he assumed the matter was made of indivisible atoms. It's like, in this case, he believed the atoms was like balls, like solid balls. That the atoms was indivisible. But now we know the atoms are not indivisible. They are made the small particles, and we know now the atoms has electron, nucleus, and the nucleus has protons and neutrons. And now also we are able to see the electrons. Using the electron, the transmission electron microscopy, we are able to see the atoms. This is a real picture of this compound, titanium neodymium oxide, and here we can see some titanium and neodymium atoms. this picture is magnified 7,800,000 times. Then now we are able to see the atoms. What are the assumptions of the kinetic molecule theory? First, the matter is made up of tiny units of a structure called atoms. And the atoms are neither created or destroyed during any type of chemical or physical change. This is similar to the energy. Energy cannot be created or destroyed. Also, the atoms means the mass cannot created or destroyed during any chemical reaction. And depending how the atoms are organized, this determines type of the matter. Yes, depend how the atoms are organized, determine what kind of matter we have. Then, what kind of matter is, we have now? Then can be elements. Elements are pure substance made up only for one type of atom. This is like the periodic table we had. Then, for example, copper, nickel, gold, lithium, and just one type of atom. But the compounds have more complex structure, and they can be composed of two or more elements. But these elements are in defined proportions. For example, we had water, and if we had water, we know we had 2 hydrogens, 1 oxygen. If we had salt, which is sodium chloride, we had 1 to 1, 1 sodium, 1 chloride. And there are more complex structures, for example, sugar. In this case, we had 12 carbon, 12 hydrogen, 11 oxygens. And the small particle of a compound is a molecule. And the molecules is the small part of the compound that maintain the identity. If we don't have 2 hydrogens and 1 oxygen, then we have different molecules. Then this is the small part of the compound is the molecule. Now, how the molecules of the compound interact, or how the molecules of 2 different compounds interact. Then if we had the same kind of compound, there is a force that keeps these molecules together, and this force is called the cohesion force. If we had 2 different kind of molecules, then these 2 molecules stick together by adhesion forces. Then, for example, in this case, the molecules of the water, they stick together by cohesion force, but the drop of water stick to the pine needles by adhesion force. Depend on how strong are the cohesive forces between the molecules or the atoms of the substance, then we will have 3 different phases of matter. It can be solid, the substance can be solid, liquid, or can be gas. And let's start explaining the solid. And in solid, the molecules are really organized, and they can just only vibrate. They cannot translate, they cannot rotate, they can just vibrate in one fixed position. And this is why in this case there are strong cohesive forces between the molecules. Because the molecules cannot rotate, cannot translate, then the shape and the volume of the solids are fixed. Now, what happens if we add energy to that substance? Then now the molecules will have more energy. Then the molecules in this case, they can vibrate, but also they can rotate and they can move, they can translate a small distance compared with the size of the molecules. In this case, the cohesive forces are not strong as in a case of the solids. Because now they can, the molecules can move a little more. This is why in this case the shape is variable, but however the volume is fixed. Now what happens if we add more heat or more energy to that substance? Now the molecules will have high kinetic energy. They can vibrate, they can move, they can translate larger distance compared with the size of the molecules, and they can rotate. And because they move faster, they had high kinetic energy. Then now this is why the shape and the volume, in this case in gases, are variable. Then another important thing is in case of the liquids and gases is they can flow, because they can rotate, they can translate, they can flow. But solids, they cannot flow. Yes, because in this case, in the case of the solid, the molecules, they are in fixed positions. Then now we know the molecules can move in three different ways. In a substance, the molecules can move in three different ways. Can be vibrate, can be rotate, can be translate. But if they can rotate, they can vibrate, or they can translate, depend on how much kinetic energy we add to the substance. Yes, if we add more energy, they can move faster, they can translate, they can rotate. Then what happens is, if the molecules have more energy, they can move faster. Then if we measure the temperature of that substance, for example, if the water is boiling, then we will measure higher temperatures. But if the substance is cooling down, then if we measure the temperature, we will see the temperature is slow. Then we can associate, if the molecules of the substance are moving faster, we will have higher temperature. If the molecules in a substance is moving slow, then we will measure lower temperature. And now we can define, the temperature of a substance is a measure of the kinetic energy of the molecules. And when we are measuring the temperature of a substance, what we are really measuring is the kinetic energy of the molecules, how faster or how slow that molecules are moving. To measure the temperature of any substance or object, we use thermometers. But what the thermometer really measures is the kinetic energy of the molecules that make up this substance or this object. How the thermometers work is, when the thermometer is in contact with the substance, the kinetic energy of that substance is transferred to the thermometer, and then the thermometer is made with some substance that has some property that respond to that change in kinetic energy. And in this example, we had the mercury thermometer that is really not used too much now, and we had the alcohol thermometer. And the property that responds to this change in kinetic energy is the expansion. And what happens is, when there is change in kinetic energy, then this mercury or this alcohol, they expand, and this is how we can measure the temperature of that object. In the same way, we had units to measure the energy or the work or the force or the velocity, and we had some units we can use to measure the temperature. And this is why we had thermometers scales. And we had three different scales to measure the temperature. One is Fahrenheit, the other is Celsius and Kelvin. And Fahrenheit is the scale we know we use in this country. Then we know there are some important temperatures in these scales, and one is the freezing point of the water, that is 32 Fahrenheit, boiling point of the water, which is 212. The other temperature is the absolute zero temperature, and in Fahrenheit correspond to minus 459 Fahrenheit. In this temperature, the absolute zero correspond to the temperature, the kinetic energy of the substance is zero. No vibrations, no rotation, no translation. It's zero. No one has reached to this temperature up to now. Everything is freezing. Yes, there is no rotational, no translation, no vibration. The other temperature that is used in other countries and also in science is the Celsius temperature, and I need you to remember these two temperatures in Celsius. The freezing point for the water in Celsius is 0 degrees Celsius, and in boiling temperature of water is 100 degrees Celsius. Then I need you to remember these two temperatures because we will use to solve many problems. And in this case, the absolute zero temperature in case of the Celsius is negative 273 Celsius. And the other temperature, the other scale we use is Kelvin. And you can see in this case there is no negative temperatures. And this is when in science, when you are doing some calculations, it is a problem if you had negative temperatures. This is why in science, in many cases, we had to use this scale because it's to avoid problems in calculation. We need only positive. We need to have just positive temperatures. And you can see there is no negative temperature in this case. And 0 Kelvin corresponds to the absolute zero. One more thing I want you to see between the freezing point of the water and boiling point of the water, we had 100 divisions in case of Kelvin, 100 divisions in Celsius scale, but in case of Fahrenheit, we don't have 100 divisions. And this is why when we need to convert from one unit to another, in case of Fahrenheit and Celsius or Fahrenheit and Kelvin, we will have some fraction in the equation, and this is the reason. Yes. But if we need to convert to Celsius and to Kelvin or Kelvin to Celsius, then we don't have fraction in this case, and this is the reason. Yes, we have 100 divisions between these 2 points. Then to convert from one temp to one scale to another scale, we had this equations, and you have to be careful when you convert from one unit to another unit with the math, and to do that, just follow the PEMDAS rules. Yes, and if, for example, in this case, we first multiply and then we add. In this case, first we solve the parentheses and then we multiply. Here, no problem. The last one. And just to review quickly the procedure, let's do some examples. And in this case, the average human body temperature is 98.6 Fahrenheit. And what is the equivalent temperature on the Celsius scale? And in this case, we want to convert 98 98.6 Fahrenheit into Celsius. And we know the equation we need to apply in this case is this. And let's write this equation here. And we need to convert 90.6 into Celsius. And let's write this. Then this temperature, the Fahrenheit, is 98.6. Then first we need to solve the parentheses. Then 98.6 minus 32 is 6.6. And let's now, first we multiply 5 times 66.6 will be over 9. And finally we divide 333 divided by 9 will be 37.0, and this is Celsius. And here we will say 98.6 Fahrenheit correspond to 37.0 Celsius. One more problem. A bank temperature display indicates 20 degrees Celsius. This is about room temperature in this scale, 20 degrees Celsius. And what is the equivalent temperature on the Fahrenheit scale? Then to convert from Fahrenheit to Celsius, we will apply this equation. Then we want to convert 20 degrees Celsius into Fahrenheit. And let's and the temperature in Celsius is 20 degree plus 32. And in this case, first we multiply by 9, and you can skip some of these steps, but I am explaining step by step, just I want to be clear. Then 9 times 20 will be 180 divided by 5. And now we will have 36 plus 180 divided by 5 is 36. We add them. And finally, we need to add 36 plus 32, which is 68. And we know the answer is Fahrenheit. And if we want to convert 20 degrees Celsius into Fahrenheit, we will have 68 Fahrenheit. Now let's complete one more problem. In this case, a science article refers to a temperature of 300 Kelvin. Then we want to know what is the equivalent of 300 Kelvin in Celsius and what is the equivalent of 300 Kelvin in Fahrenheit. And in this case, we have 300.0 Kelvin, and we want to convert this one into Celsius. And we need to apply the first equation. Because we want to convert into Celsius, then we need to solve for Celsius first. Then here we will have Kelvin this. And now let's calculate. Then we will have, let me write this one. And what is the temperature in Kelvin is 300. And here, if we want to be really careful with the significant digits, we will have, this is the answer. And in this case, we will say 300.0 Kelvin is 27.00 Celsius. In the second part, we want to convert 300 Kelvin into Fahrenheit, because we don't have direct equation that convert Kelvin into Celsius. And what we will is we will convert 27 Celsius into Fahrenheit. Then we want to really convert this one into Fahrenheit, and we are going to convert this 20 . And for that, we will use the second equation. Then and now the temperature in Celsius, which is 27 plus 32. Now if we multiply this, we will get 243 divide, this is a point, plus 32. Then finally we had 48.6. Finally we had here 80.6. This is in Fahrenheit. And here we can say convert this one into Fahrenheit will be 80.65. Then now we had 300 kelvins correspond to 27 Celsius and correspond to 80.6 Fahrenheit. To 80.6 Fahrenheit. That's why here complete conversion. Fahrenheit. Then now in the next presentations we are going to focus in the concept of heat. And this is all we are going to discuss in this presentation.